Alright, let's look at an example for equations of planes. Right, let's find an equation of a plane containing 3 points. Negative 1, 1, 1, 2, 3, 0, and 0, 1, negative 2. Right, I already drew a picture of, ballpark picture of the plane and the 3 points. Right, so what we need is a normal vector. So we need a 1, right, normal vector, so vector n. And the second thing we need would be a point. So let's call it R0. And you can use any 3 points. Maybe I'll just use 0, comma, 1, comma, negative 2. Alright, then so all we need is the normal vector. Alright, so let's try to find the normal vector. Alright, so we can think of 2 vectors coming out of 0, 1, negative 2. So here's one. Alright, let's call it vector A. Right, and the other one is coming out of 0, 1, negative 2, 2, 3, 0. So let's call it vector B. Right, but we are interested in a normal vector which points in this direction, which has to be perpendicular to both A and vector B. Right, we know a vector that is perpendicular to both, we can just take the cross product. So let's take the cross product, vector A cross vector B. Right, so this is going to be, right, so first row is I, J, K. Then vector A would be, right, so we need to find out the vector A. So vector A is, maybe I'll write it here. So vector A is negative 1 minus 0, so it's negative 1, comma, 1 minus 1, so that's 0. And 1 minus negative 2, so adding 2, so it's a 3. Right? So we have a negative 1, 0, and 3. Alright? And the vector B would be, right, 2 minus 0 is 2, comma, 3 minus 1 is 2. Right, 0 minus negative 2 is positive 2, so it's all 2's. Right? Alright, so it's going to be 2, 2, 2. Right? We can rescale it to 1, 1, 1 as well, but I'll go with 2, 2, 2 for now. Alright, then take the cross product. So it's going to be, first component is going to be a positive. Then let's see, you have 0, 3, 2, 2. Alright, second component is negative, and determinant of negative 1, 3, 2, 2. And the third component is going to be positive, and then determinant of negative 1, 0, 2, 2. Alright, then we can compute that. So this is going to be equal to, that's 0 minus 6, so it's negative 6. And the negative, and this is going to be negative 2 minus 6, so it's going to be negative 8, so it's going to be positive 8. Right, then you have, let's see, negative 2 minus 0, so it's negative 2. Right, so if you want, we can pull out negative, maybe, and pull out 2, or yeah, let's pull out 2. So it's going to be negative 3, 4, and negative 1. Right, so we can take, let's say, this guy to be the normal vector, because all we need to know is the direction, so we don't have to have the same magnitude, and I like smaller numbers. Alright, so normal vector, we can take that to be -3, comma 4, comma -1. Alright, so therefore, once you know these values, so these give us A, B, and C values, and here these gonna give us x0, y0, and a z0 value. So therefore, then equation would be, right, A would be -3, quantity x minus x0, which would be 0 actually, so it's going to be just it's going to be just the x, so I'm going to just erase that. Alright, and then next number is plus 4 times y minus y0. y0 is 1, and minus z minus z0 is -2, so it's plus 2 is equal to 0. Alright, so that is the equation of the plane containing those given 3 points. Alright, that's it. I hope that this was clear.